Do you know, Cosmo, 10 years ago on the 4th July 2012, at the Large Hadron Collider, scientists have discovered the Higgs boson? Yeah, absolutely, I know that. But do you know that why the discovery of the Higgs boson is important? Well, I don't know that. Look, the Higgs boson proved the existence of the Higgs field, which is responsible for the mass of the elementary particles. And the theory of the Higgs field was proposed by the Peter Higgs and other scientists in the 1964. But how come it can give the mass to some particles? Look, Higgs field is unusual. It is a scalar field, and at the ground state, instead of the zero value, it has a non-zero amplitude everywhere, which is responsible for the symmetry breaking, and that triggers the Higgs. Hey, wait, Cosmo. What is the symmetry breaking? Oh, look, gauge bosons and the other fundamental particles are massless, which is a symmetrical condition, and in the presence of the Higgs field, this symmetry is broken, and everyone has a different mass. To understand that, you can take the analogy of the light. In a vacuum, all the wavelength of the light has the same velocity, which is a symmetrical condition. But in the presence of the medium, such as the glass, every wavelength has the different velocities. So this is a symmetry breaking, which triggers the Higgs mechanism, which resulted as the existence of the Higgs field, and the particles that interacts with the Higgs field gains the mass. This happens because the scalar components of the Higgs field are absorbed by the bosons as the degrees of the freedom and decouples with the fermions, and hence they get the mass. The particles those do not interact with the Higgs field stay normal. It is like a charged particle affected by the electric field and pulled around, whereas the neutral one remains the unaffected. So this is how the particle gets the mass.